Hey everybody, this is the first video of our last chapter for the school year, and really this chapter is just going to be a collection of different topics that come up in our FRQ. So we're really kind of putting everything together that we've learned this year. So the first idea we're going to work with is average value. And so we had a chance to look at this a bit in class, but really if we're asking to find the average value of a function, there's kind of two ways that we think about it. Right? The first way is it's the level of y that explains where a function would level off if we spread out all of its area equally. So if I look at this function here, obviously that area in gray is what I would get if I integrated this function. Right? If I call this my a and this b here, that would be the integral from a to b of f of x dx. And if I did that, I would get that area in gray. Now, this line here that represents my average value says that if I were to take that area, the gray area, and I were to kind of level it off, this would be the point where if I spread out that area evenly, it would match this line. So in other words, if I look at this, all of this area above would fit into this negative space down below. So if I could spread out that area evenly, it would level off at this line here. So that's how we think about it from a graphical perspective. Now, another way to think about it, right, is that when we're calculating the average value for a function, what we're doing is essentially adding up all of the y values over the interval and then dividing by how many we added. So in other words, we're averaging the values. So now, the formula for finding the average value of a function, right, if we look at this idea here, we said we were adding up all of the y values. Well, I know a way to add things up is to integrate. So I'm going to take the integral from a to b of f of x dx. But then we said we had to divide by how many things we added. So we have to divide by the length of that interval, which is b minus a. So this really gives us the formula. However, the way we see it presented in calculus, we're just going to write this 1 over b minus a times the integral from a to b of f of x dx. And that gives us the formula for finding the average value of a function. So let's go ahead and see how we would apply this. So example 1 gives us a function f of x. It asks us to find the average value of the function on a given interval. It asks us to do it without a calculator first and then check using a calculator. I'm going to scooch this up here. So let's see what we have to do here. All right. My interval here is from -1 to 2. So this is my a and b. So using the formula, I know I have 1 over b minus a. In this case, I have 2 minus a -1. I'm going to take the integral, again, from a to b. So my bounds are from -1 to 2, and I'm going to integrate that function. So in this case, I have 1 plus x squared dx. And so if I evaluate that, that will give me the average value of the function. All right, so first I'm going to go ahead and simplify. 2 minus a -1 is just going to give me 3. So I have 1/3. Now I'm going to kind of keep that out to the side. To evaluate this integral, I know I have to find the antiderivative. That's going to give me x plus x cubed over 3 plus c, and I'm going to evaluate that from -1 to 2. So let's see, I have 1/3. Now I have x is 2 plus 2 cubed is going to give me 8/3 plus c, and then I have subtract a -1. Let's see, a -1 cubed is going to give me a minus 1/3 plus c. And let's see what we can simplify here. I know my c's are going to go away. I have 2 plus 8/3. I'm going to have plus 1 and plus 1/3. So I'm just about to the end here. Now I have 2 plus 1 is going to give me 3, plus 8/3 and another third is 9/3, so that's 3 more. So 1/3 times 6 is going to give me an average value of 2. So again, the idea is that if I were able to add up all the y values of this function from the interval of -1 to 2 and divide them, I would have an average value of 2. Now, it says to do this without a calculator, then check. So obviously now I can just, whoops, let's get out of here. I can just type in what I've got. So I had 1/3 times math 9, my integral from -1 to, -1 to 2. See if I can get this right. There we go. Of 1 plus x squared dx, and that's 2. So we know we're right. So that's just the mechanics of how we work through this. All right. So now this is kind of really dealing with how do we even know we're being asked to use this formula, right? When would I use the average value formula? So this is kind of going to sound silly, but hopefully it gets the point across, right? When a problem asks you to find the average, and I'm going to say the average something, and then gives you a function to describe that something, you need to find the average value. So for example, a problem might ask you for the average temperature, and they're giving you a formula for temperature. That's when I use average value. They might ask me for the average cost and give me the function to describe cost. That's how I know I need to find the average value. So we're going to do 2 more quick examples, and then you'll get on to practice tomorrow. So it says, one day a strange weather system moved into town, and the temperature in degrees Fahrenheit over the next 24 hours was given by this formula. So they're giving me a formula for temperature. Okay, and that says, what was the average temperature over that time period? So again, to go back to our kind of silly generalization here, they asked me for average temperature and they gave me temperature. So that tells me I'm going to use that average value formula. So let's find out. It asks us what would the average temperature over a 24-hour time period. So this T is between 0 and 24 hours. All right, so we know, again, our formula is 1 over b minus a times the integral from a to b of our function f of x dx. So let's apply that to this problem. In this case, our interval here is from 0 to 24. Right, that's my a and b. So I'm going to have 1 over, now I have 24 minus 0 times the integral. Again, this is my interval, my bounds for my integral. Now my function is my temperature formula here. That's what I'm integrating. Okay, so I'm going to integrate 70 plus 2 sine of t over 2 minus t over 2 dt. Again, I'm going to keep my variables consistent there. And for this, we're just going to use our calculator. So I'm going to go to my calculator. I've got 1 divided by 24 times the integral from 0 to 24 of 70 plus 2 sine x over 2 minus x over 2 dx. And I get 64. Let's see if it tells me how to round. It doesn't, so I'm just going to do it to 3 places. 64.026 is my average temperature. Now, the big question is, what would the units on your answer be? So here's where we have to think a little bit. I'm going to think about this. If I were going to plot this on a coordinate plane here, my x-axis is going to be the time. And I have here my function is temperature, and that's in degrees Fahrenheit. I should mention my time is in hours. So if we think about units here, I'm going to grab another color. When I'm integrating, so for this portion, oops, should have stopped there. For that portion there, when I'm integrating, I'm finding that area. So I'm multiplying my base times my height. So what I have here is really hours times degrees Fahrenheit. Right? Now, on this end here, what I have is 1 over the 24 minus 0, that's my hours. So really when I look at this, I'm doing 1 over hours times hours times degrees Fahrenheit. So I notice my hours are going to cancel, and I'm left with units of degrees Fahrenheit. So I want to do a quick check to make sure that makes sense. Right? My question is asking, what was the average temperature over that 24-hour time period? This tells me my average I would expect would be measured in degrees Fahrenheit. All right, let's look at one more example. All right, so we have, suppose that C of t represents the daily cost of heating your house measured in dollars per day, where t is time measured in days, and t equals 0 corresponds to January 1st of 2010. So this is asking us to interpret this expression using units in the context of the problem. Now, the first thing we need to recognize is that this is the formula for average value. Right, so I need to recognize that formula and realize this is then, if C of t is the daily cost of heating your house, then this, being the average value, is going to be the average daily cost, of heating your house. Okay, so we would say 1 over 90 minus 0 times the integral from 0 to 90 of C of t dt represents the average daily cost of heating your house. Okay, that's kind of part one. So recognizing they gave us the stuff, right, the average daily cost of heating your house, and this represents the average of that, the average daily cost of heating your house. Now, we need to specify, this was on the interval from 0 to 90. So that really represents the first 90 days of January of 2010. So it represents the average daily cost of heating your house over the first 90 days of 2010. And then we need to make sure we include our units, right? That cost was measured in dollars per day. So it's the average daily cost measured in dollars per day. Now, how is this different from the integral from 0 to 90 of c of t dt? Again, let's think about this maybe if we were going to graph it. Right? Our time was days. Right? Days since January 1st of 2010. Our y-axis was the daily cost. And that's measured in dollars per day. So when we're integrating, again, we're multiplying our base times height. So we would have days times dollars per day. So that would just cancel and give us dollars. So when we're integrating, the integral from 0 to 90 of c of t dt represents the total cost of heating your house for the first 90 days of 2010. All right, so that gives us kind of the basics, everything we need to know for right now about average value. Obviously, if there's questions, we'll talk about those tomorrow, and you'll have to have time to practice this in a lot of different contexts. Thank you very much. That's it for today.